Okay, that's crystal clear. Okay, now condition number 3. Alright, so the operator operate the control valve open, close, depend how much percentage you want. So what happened? Changing the throttle position. Okay, if you change the throttle position, the pump flow will vary. Necessary. Why? Necessary to maintain the differential spool spring preload, the 15 bar, which is 15 bar delta P. Okay, if the pump will not change, the delta P is out from the setting. Okay, so if that happen, if the delta P is increased, then the pump will decrease. Okay, so this spool will move to the left. If the delta P is decreased lower than the delta P setting, this spool will shift to the right. Okay, and then the pump will stroke up. Okay, until such time the delta P is balanced, then this spool here will close. Alright, otherwise the pump will continue stroking. So this is the feedback. This signal here is, this load sense signal is a feedback. Okay, so this spool here is like that, doing like that to balance. Alright, to balance, to maintain that delta P, whatever you set here. This time we set to 15 bar. Okay, so changing the throttle position, this one here, which is the act as a control valve, will vary the flow necessary to maintain the differential spool spring preload, this one here, which is the 15 bar. Okay, the pump will automatically vary its stroke to maintain the load sensing pressure drop constant. Okay, so if you have 15 bar delta P, it will maintain 15 bar delta P. Alright, okay, so remember, when you close the control valve, if you decrease the area of the control valve, the delta P here will rise. What happened? This spool will move to the left. If the control valve opening is wide, the delta P here will decrease, because according to the Bernoulli's equation, once the area is increased, the delta P is decreased. So meaning, if that happen, this spool here will move to the right, and then it will max stroke, which is correct, because the control valve is opening wide, so you need more flow. So meaning you need max stroke. All right. So this load sense control, this system here, the pump will give flow only according to the demand. So if the operator wants 50%, the pump will give 50%. Why? Because it will maintain the pressure differential across the delta P. Alright, so another condition. If the operator totally closed the control valve, not using anymore, so what happened? Okay, now if there's no use, alright, so control valve is fully closed. What happened here is the pump, because the pump is in a max stroke, so it will displace flow and then create pressure. Now this gallery here, alright, is the system pressure. Okay, now the pressure now acting on the spool. What happened? Because the pump is a positive displacement pump, so it will create infinite pressure if you don't limit that pressure. But this spring is set only to 15 bar. Okay, delta P, but the standby, this is the standby mode condition. There's no load sense feedback signal here because the control valve here, this throttle is closed. So there's no downstream pressure. So meaning the LS is drained. Alright? So when the LS is drained, the remaining force here is the spring force. Okay? Now the standby is higher 1 bar or 2 bars than the delta P setting. So if you set this to 15 bar, the standby will be 16 bar. Okay? So once the pressure reaches to 16 bar, this spool here will shift to the left, and then allowing the system pressure and this stroke port common or open. Once that happens, the pump will de-stroke enough to maintain the 16 bar standby pressure. So that is the standby mode. Alright, so when the control valve is closed, the pressure, the mode, the condition of the system is standby. Depend how much setting you put in this spring chamber here in the upper spool. Okay? Alright, so what about the cutoff? Alright, so the cutoff, let's say the throttle valve is fully open. So not much delta P happening there. But as the load increase, the upstream also will increase. Okay? As the load, because the load is in the downstream position. So when the load increase, of course, the pump also will increase pressure until such time, because it's the downstream and the upstream are almost the same pressure. So what happened here is this spring here, which is set to 280. Once the 280 is reached, this spool here, okay, this spool, by the way, is remain in this position to the right, because the pressure here and the pressure in the upstream are the same, and then plus the spring force. So this force here is higher than the upstream. So what happened? This spool here will regulate the pressure cutoff. So once the load reaches to 280 bar, so the upstream pressure is 280, the downstream pressure is 280. So meaning this spring here will overcome this spring here, because we set this to 280. What happened? This spool will move to the left, allowing the system pressure and the stroke port piston open, then closing the case and the stroke. So meaning system and stroke piston is open. Then the pump stroke will cut off, but to maintain 280 bars. So that's the difference between the cut-off and the standby. The standby is low pressure only, but this spool here, in the standby, the spool up at the upper is regulate. But during cut-off, the spool at the bottom is regulate. Okay, so the pump will minimum enough to maintain the 280 bar. When the pressure drop 280 bar, of course, this force here is higher, then this spool will back to its position. Okay, so that's how the load sense type controller of the pump works. So this is the feedback here. The pump will regulate to maintain the delta P. As you move the control valve, the pump flow will regulate, okay, to maintain the delta P. So if you close this, the delta P here will increase. So meaning this spool at the top will shift to the left. And then once the flow rate is enough to maintain the delta P, and then it balance. Okay? Alright. So the load sense graph, okay? Okay, the load sense, okay, graph is like that. I like graph because it's easy to understand what's happening and how the pump works, okay? So P and Q. So all right, this one here is your standby, okay? This one here is your 280 bar cutoff, but you can set the cutoff to here and to here. All right, good. Then you can set also your flow at max. This is the load sense. You can set the flow here through the control valve. You can set the flow here by regulating the control or the throttle valve, and you can set the flow here regardless of pressure and RPM. So if once the flow is set regardless of pressure, it will not change unless the pump efficiency is bad. Then it will change because you have too much leakage, or unless the load is almost reached to the pressure cutoff, and because it almost reached the pressure cutoff, the swivel is regulating to minimum. Okay, so that's the load sense. Okay, you can set the flow either in this point regardless of RPM and pressure. Okay, RPM is a bit tricky because the lower the RPM, again the efficiency of the pump will affect, so it will drop the flow, especially when you load it. All right. So that's the load sense. This is the DFR and DFR1 principle. Okay? So I hope guys you understand the load sense pump, okay? System or the load sense controller. Okay? If you have question, just comment on the on my page, and then I will give answer as I can. Okay, thank you.